Okay, question number 3. This question will be published on 4th December, Wednesday. Okay. A student measures the refractive index of water by shining a light ray into a transparent container. Okay, fine. So this is the light ray, transparent container. A IO shows the direction of the normal at the point where the light is incident on the container. Okay, so this is your incident ray. This is my normal. IO is the normal over here. So let me write this as normal here. Right. So with respect to the normal only, we are going to measure the angle of incidence and angle of refraction. So what is this one? This is nothing but your angle of incidence. Okay. Ix shows the direction of the light ray when the container is empty. When the container is empty, there is no refraction. It goes straight like this. Okay, fine. And Iy shows the direction of the deviated ray when the container is filled with water. When you are filling this with water, this gets deviated like this. Which is a refractive angle? This is my refracting angle, R. Okay. The angle of incidence theta is varied and the student determines the position of O, X and Y. Okay, so whenever we learn about refraction, what comes to our mind first? Let us write down that. Okay, so we will write, I didn't start the timer. Okay, this we'll write sine theta divided by sine R is equal to mu. What is this? Snell's law. Okay, which we know. Then next. Table shows the data collected by the student. Uncertainty in each measurement length is plus or minus 0.1 centimeter. Uncertainty in each measurement, okay, which means is giving you delta ox is equal to delta oy is equal to 0.1 centimeter. Okay, so because it's centimeter, I can easily realize this should be an absolute uncertainty, not a relative one, right? Did outline why oy has a greater percentage uncertainty than ox for each pair of data points. Okay, he is asking you why delta oy divided by delta oy divided by oy percentage is greater than delta ox divided by ox. This is a question. How do you prove? Okay, so here he says outline, and this for how many marks? Only 1 mark. So you need to mention the reason here. How do you mention the reason? Now if you look at oy and ox over here, so it's 1.3, 1.8, 2.6, 3.6, 4, 5.8. What's the pattern you look at? You always see that oy is greater than ox. See, first 3 points I have seen. Just verify for everyone. 5.1, 8.4, 7.3, 11.9. OY is, oh sorry, not OY is, OY is less than OX. OY is less than OX, right? See, OY is 9.5, 17, 17.3, 12.2, 27.4. Everywhere OY is less than OX. So if OY is less than OX, which means 1 by OY should be greater than 1 by OX, correct? Okay. Now what you need to write? Since OY is less than OX for each pair of points, therefore 1 by OY is less than 1 by greater than 1 by OX. In other words delta OY divided by OY is greater than delta OX or delta OY divided by OX, because you may ask me why did you put this OX here. So instead of it, I'll tell you I multiplied on both the sides on the numerator by delta OY. I'll write like this. Okay, but we already know the delta OY is equal to delta OX. Where do I know? I know from here. It's already given to you, right? So what I will do is I will just substitute here and I will write delta OY divided by OY. I'll retain this, while this one I'll write this as delta OX divided by OX. I replace delta OY by delta OX. That's it. So therefore we have already proved, right? And hence the result. Okay. Right. Next. So next one is the refractive index of the water is given by OX by OY. So mu is given by the OX by OY. Formula is given when OX is small, when OX is small. Okay, remember there is a condition given here. Calculate the fractional uncertainty in the value of the refractive index of water for OX equal to 1.8 centimeter. You need to find out the fractional uncertainty. He is not asking you to find out the value of the refractive index. So how do you find? You know, delta mu by mu is what you need, which should be delta of OX divided by OX plus delta of OY divided by OY, right? So you just need the values over here. What is delta OX? Delta OX value is already given to you. Where was it given? It's given here, right? So just substitute that value, which should be 0.1 divided by, what's the value of OX? OX is 1.8 plus this is also 0.1 divided by, what is your OY? OY for 1.8, OY for 1.8 is 1.3. Okay, so take from the data, which should be 1.3. Now let us use your calculator to find out what is the resultant answer. So use your calculator Now I'll write 0.1 divided by 1.8 will give me 0.0.0.055 plus this 0.1 by 1.3. 0.1 divided by 1.3 should be 0.077 plus 0.077. When I add these two, what do I get here? We cancel this 0.077 plus 0.055. When I add the 0.132, 0.132. So this has how many significant figures? This has two significant figures. So your answer should also be only two significant figures. So this is the right answer. Delta mu by mu is equal to 0.13. Okay, let us move on to the next one. A graph of the variation of OX versus OY is being plotted. Okay, draw on the graph the error bars for OY when OX equal to 1.y and when OY is equal to 5.8. Now, first remember, how do you draw the error bars? What is an error bar? So if this is your point, then this is my error bar over here. This length should be equal to your absolute error. Okay, this should be equal to, say for example, if it is along OY, so you should now be equal to delta OY, which is nothing but 0.1 centimeter. That's what you need to do. Now, what is he asking? Draw error bars only for OY. Okay, not for anything else. When OX equal to 1.8 centimeter, what is OY? When OX equal to 1.8 centimeter, what is OY? Let us go back. The value of OY is 1.3. Now, let us go back to the graph over here. When OX equal to 1.8, 1.8 is somewhere over here. This point is asking. For this point, it should be 0.1 centimeter. You should draw the error bar. Now look at this here. This is 0, this is 1 over here. What does each small box represent? 0.2 centimeter. Okay, if this is 0.1 centimeter, this should be 0.1 centimeter once again, right? Which means the total length is 0.2 centimeter. So if this is the mid box over here, this is a mid box or mid point over here between these two boxes, then the error bar should look like this. This should be your error bar. Done, right? This is your error bar. Okay. So 1.8 we have done. Now 5.8. For 1.8, you need to map this value and get the value for 1.3 centimeter and then do it. For 5.8, no mapping, nothing. You can directly look into it. 5.8 is where? 5.8 is this point, right? So therefore, now here also what you need to do? Draw a line like this. That's it. Okay, we are done with the writing the error bar. Determine using the graph the refractive index of water in the container for values of OX less than 6 centimeter using the graph. Okay, when you say using the graph, what you should do? You should either find the slope or area or intercept. Any one of them you need to find. Now he is asking you this one. I'll do one thing. I'll just erase this. I'll erase this point. So it becomes easy for me to locate. So what I do is points is given, scatter plot is given. Now what I should do? I should draw a line to find the slope. From here, I will draw a slope. I'll draw a line so that you get the slope here. Okay, it's like this, it goes. Now you see, he is asking you for OX less than 6 centimeter, which means he is assuming the slope can be drawn only here. See, these are some of the clues that you need to read in between lines. Now towards it, now I'll take this value and I will take this value and I will draw the slope here. I'll draw it like this over here. It's a bit curved, looks like. Okay. Now what I'll do is, what is this value here? Corresponding to OX nearing to 6. I was 6 and 4. I'll take it directly from here. Okay. OX equal to 6 is 5.8, 5.8 and 4. So 5.8 and 4. Which one is this? This 5.8 and 4 is this one. This point is 5.8 comma 4. And this, what is this value here? This value should be at OX equal to 6. This is 5.8 comma. And what is this value here? You should have a value equal to something like 1.4, I think, right? Do I have a value equal to 1.4? Let us check. 1.8 OX equal to, what do I need? I need the value of y here, right? For the value of y, which value we have? 1.3 here. Value of 1.3 we have. Is 1.1, 1.2, 1.3. 1.3 here. In a similar way, if you look at this value, this 1.8, do I have an OX value equal to 1.8? 1.8 you have, right? I'll take this value as 1.8 because I looked at the cross here. 1.8 comma, this value, this height is nothing but 1.3, right? This height is 1.3. I have written this. Now coordinates are written. I need to find the slope. The slope here, I'll write slope here, should now be equal to delta delta Oy divided by delta Ox. Delta Ox. Change in y values by change in x values. So what should this be? 4 minus 1.3. 4 minus 1.3 divided by change in x values. What is it? 5.8 minus 1.8, which is 4. Okay. Now let us calculate what is this value here. This value should be 4 minus 1.3 should be 2.7. 2.7 divided by 4. Okay, we have got this. This doesn't have any units because centimeter here. Now we have got slope is equal to 2.7. Sorry, 2.7 divided by 4. 2.7 divided by 4. Now what is he asking? Refractive index. Now we know that mu is equal to Ox by Oy, or maybe in a graph this should be delta Ox by delta Oy. What is that we have got? We have got the slope to be delta Oy divided by delta Ox, right? So I should now consider this to be equal to 1 by slope, which should be, slope is 2.7 by 4, should be 4 by 2.7, right? So let us use our calculator to find out what is that value. So I'll get 4 divided by 2.7 comes out to be around, I missed it. So 4 divided by 2.7 comes out to be 1.48. So I got the answer as 1.48. Okay. Now you see, this is 6.0, this is 2.7 and so on. So therefore this should be, I can approximate this and write this as 1.5. Okay. So I got the refractive index of water to be 1.5. Do you think it's correct? No, it's not correct, right? Because you know refractive index of water is 1.33. Okay, let us proceed further. Refractive index of a material is also given by sin I by sin R. I already written this. Let me erase this and explain this from the very beginning. Okay, so that you understand this. This I did it for a given class. So maybe before this I made a recording. Anyway, now. So now refractive index of a material is given by sin I by sin R, also where I is the angle of incidence. Okay, we already know, I already written that mu is equal to sin I by sin R. Outline why the graph on page 4 deviates from a straight line for larger values of Ox. For larger values of Ox, now you see this graph goes like this over here. It goes like this over here, right? But you see the points are going like this. So what you should do, you are supposed to write like this over here. This should be the curve that is being expected. So why does it change for larger values of Ox? Now let me go back here. For larger values of Ox, what is Ox over here? Ox is this angle. If this Ox changes, that means this angle theta also changes. Okay, if I write down, if Ox increases, value of theta increases. When the value of theta increases, that means you're keeping it over here. You're keeping it over here. When you keep it over here, might be you will get something like this. You'll get something like this over here. So this would be your x point. This would be your Ox over here, right? So therefore the value of theta is changing. Now what we do is, if the value of theta is changing, then I am getting a different answer. That means for larger values of theta, I am getting incorrect values. For smaller values of theta, I am getting an appreciably better values. That's what I see. Okay, so therefore, why is this dependent theta coming here? What we do is, let us see whether we can derive this equation using this here. So now, if this angle is theta, I can now write tan theta. Tan theta is equal to Ox divided by Oy. And tan R is equal to Oy. This is your Oy. You are taking this triangle, right? Oy divided by Oy, right? So therefore, if I divide tan theta divided by tan R, I get this as Ox by Oy divided by Oy divided by Oy. So Oy goes away. So which is nothing but Ox by Oy, right? So now what is Ox by Oy? Mu. So therefore, if I use a geometry in the figure here, I get the value of mu given by tan theta by tan R. If I use the Snell's law, I get mu equal to sin theta by sin R. Now which equation is correct? Okay, this is the question. Let me go back to my question over here. So I have mu equal to sin I by sin R or sin theta by sin R is the proper Snell's law, theoretical law. And if I look at the diagram from geometry, I am deriving mu equal to tan theta by tan R. Now if these two has to be equivalent, when will this be equivalent? These two will be equivalent only if theta is small. Theta is small. When the value of theta is higher, definitely this will not be equal. How do I know this? Why do I say this? Because we know if theta is small, Sin theta converges to tan theta converges to theta. Where did you learn this? You learned this in trigonometry. Okay, now let us come back to this question. I just explained everything. Outline why the graph on page 4 deviates from a straight line for larger values of Ox. Now what you should write here, so you should understand all this. Now what you should write is larger values of Ox implies larger values of theta. So in that case, tan theta will not be equal to sin theta, hence mu does not, the value of mu does not, what has been asked. Now let us look at this. Value of mu deviates. See, you need to copy this statement here because this was the conclusion you need to write, right? Deviates from a straight line. Okay, so we have explained all of them. Okay, now next question. Okay, so fine, we have come to the end of this question. Let us see you once again tomorrow. Thank you.